I would like to invite our next speaker, Mr. Praveen Gopal, Regional Technical Lead APAC from Mcafee, to the stage. Put your hands together. Let's welcome him on stage. The topic we'll be speaking today is understand how machine learning defends against zero-day threats. Information security specialist. He is with 15 years of experience, specialization in information technology, and able to design, implement information security system that best serves the needs. Experience in architecture, designing, consulting, implementing cybersecurity, virtualization security, cloud and data center security solution. Ladies and gentlemen, one more time I request all of you to put your hands together for Mr. Praveen Gopal.
Hi, gentlemen. It's been a long day, so I'll not take a lot of time, but let's discuss about what exactly the industry is going through. People have spoken about IoT and how the infrastructure security or the information security can be enhanced. So per se, I represent Mcafee, and I've been in Mcafee for a couple of years now, and we have been inventing what is the best way of handling the security posture, and how do we automate it? So before we get into what Mcafee does, what I would like to talk is, what is this WannaCry that we already had a bad impact on? So let's basically discuss on how the virus technology works, right? Not the antivirus technology works, how the virus technology works. So what is the detection challenge that we have? The signatures which detect the threat is going to be fading away, because one of the best examples is WannaCry, which was having polymorphic nature and was changing its signatures. Whenever there was a reference back was happening on the back end, it was not being able to detect, and hence a lot of revenue losses. Now, hence, because the signature technology is fading away, we need to have innovative technologies. So why is that required? Let's say this is a classic example. What does snake eat for lunch? Can anybody detect? As such, from a technology standpoint also, it is very, very, very difficult for a program to identify what has happened, because it does not understand what is the intention of the program which is running, which is malicious in nature, right? Sorry about it. So this is Matti Yoksha. Is nothing but in our childhood we used to play a package which gets one inside the other one. The challenge is, from a technology standpoint, the challenge is what exactly is the first icon doing, and how do I detect, because the outer shell or the outer layer is the inner layer is hidden by the 7 different layers. So an application which needs to get into the characteristics of the first one, where it is given the bigger one, whatever the doll that you can see, the characteristics only can be seen by the application is of that. So how do I get into the last one? Now the classic example is Mimicards is an application which gets security credentials of Windows or as such operating systems. Now when I run this, it does take the credentials of whatsoever the operating system it is running on. When you check on the back end, if you see the decision ratio, there are 25 different vendors categorized this out of the 57 as malicious. So a little larger application or the security vendors were able to detect this can be a malicious program running. However, what I do is I intelligently place, right, maybe cards with another native or compiled binary, by which what happens is the characteristics of that program being hidden by another program. Hence, all the applications which try to identify if this is a malicious program or not is not able to detect what exactly is this program. Now, because I used a compiler, my detection ratio is 11 instead of 25. So this is the replica how the WannaCry gets in. It is a simple encryption algorithm written by somebody but encapsulated by very different programs which cannot identify the actual intention of the program. So the world are the intentions of the end users. Basically, it could be a corporate person who is having a malicious intention, or it can be in the internet. Now we talk about hybrid networks. It can be on the cloud applications which are running by the corporate. So there are many vectors from which the threats can come. What are the approaches? We in length spoke about the machine learning. So I want to give you an analogy of how the machine learning works. When we understand how does it work, our applications are also so much robust to identify how the viruses work and how an antivirus can basically identify with more precise or more accurate analogy, right? So these features are basically static analysis. Some gentleman was certainly talking about fuzzy logics, fuzzy hashing, import address hash, dynamic analysis, memory analysis. These are all something that a machine learning process as such run, right? To identify various features or the characteristics of a program, a human being, whatsoever. I mean, machine learning can be on anything, Fitbits we talked about. So it could be anything, but these are all some logics that a machine learning program understands and try to identify various characteristics of this and come to a conclusion, right? A program is so robust as many information it can gather and put to a logical conclusion that this can be good, bad, ugly, whatsoever. So there are different characteristics, a pre-execution and a post-execution. Maybe many of the people who are interacting with the security vendors, you hear a lot about this, as there are some characteristics of pre-execution. What are basically of them? The file type that you use today, import hash, the footprint of that particular file, entry point from where it has come, resources, string packers, what is the string which is being used by that, are there any compilers, compile time, when has it done, are there any APIs that it uses, and the names which has been given to that particular program. These are all something pre-execution, means to say, I look at you and I get to know, at least in Indian context, I can say you are a Northi, you are a South, a person from South, by looking at you, right? So those are all something like pre-execution. The post-execution is what behaviors do I bring in that particular program? Am I making registry entry changes? Am I running in a memory place where I'm supposed not to do as a program, but as an operating system it is allowed to do, but I should not get into that. So behavioral sequences, process tree, what are all the sub-processes which runs by the program? So there was some compliances that we were talking about, saying that an application should run XYZ processes. However, by design or by intention of the OEM as well, he can run multiple other sub-processes which gives more information. Right? I'll certainly speed up because we have some time constraints, right? So extracting static features, it's one of the important features of a feature to detect if this is a ransomware. So we club together this pre and post execution. File type, what are the resources, again compile time, import address, function calls and APIs, right? Pre-execution. And then post-execution. This is a CTB locker that we are talking about, if not WannaCry. Right? Generates unique computer identifiers, which is nothing but a hash value, reboots moving itself into app data folder. So we are trying to identify when it runs, what are all different things that it is trying to generate in a system. So at the end, if you look at, if the program was allowed to make all these changes, it starts an encryption process. So if you identify this particular file or application by its behavior, because these signatures are not available in any database, this is new to the system or new to the enterprise, right? So a machine learning program starts building a hash value to each of the processes it does. Create a process, it does something in a particular folder, I associate with a name to that in the name of a hash value, right? Create a registry entry, as a program I went into a specific registry entry, I created another name to that. And so on and so forth. What I do is I start creating different hash values to identify this program is doing some malicious activity. At the end of the day, what I need to do is feature vector is, am I allowed to do this? And give a conclusion saying that yes, this program is malicious in nature or not. So very interesting analogy of this is there are set of dogs, right? How do I identify just by looking at this that this belongs to a particular breed of dog, right? It's very challenging if you look at. So what we are understanding here is there are Chihuahuas, there are Beagles, and there are Dachshunds, right? But if you see here, it's only, I mean, everything is unique, everything is same, it is not unique. So how do I differentiate? How a machine learning process differentiate these dogs into different categories? A very interesting analogy. So what I do is, I will take parameters like height and weight, because Chihuahuas, if you see, they are very tiniest of the dogs that we have, and different dogs have different characteristics. If they fall under different category, right, some dogs weight is more, so it is general analogy that we do as a graph, x and y axes. Then I do something called as UCDN distance, means to say how much distance between these objects exist. Now if you look at, when we move on, so that particular object, is it very near to the center point? We see there are at least 3 of them are near. So what I do is, that is the longest, I will take it out and group it in the other one. So likewise, I group into 3. Now I have a set of dogs whose weight is more or less equivalent to a specific breed, which is, one is a Beagle, the other one is Chihuahuas, and the other one is Dachshunds. Now I have a program which automatically detects, right, different breed of dogs. So tomorrow I can come and say I have a program that detects dogs. How I did this? Using some logic. Somebody has written a logic to identify this. And this we adopt in the information technology. When we say, do we have a family of ransomware which is running? I do categorization based on that. Is it falling on a specific registry entry or similar registry entries? Is it creating? And if it is creating, is it falling under a specific ransomware category, yes or no? So these are all some questions which can be answered by the program and categorizes that as good or bad applications which are running, right? So I'll not continue with this, probably this is understood. What I want to bring is introduce Mcafee as a product which has done an automation from the endpoints to the network side, right? So how this particular new technology works. we have been adopting whatever the standards talk about. It's basically identify, stop, analyze, take action, automate, protect, detect, correct. So protection is already there as part of the signature. We still continue to have the protection in place. However, detection is a part of the siloed applications, which is on the network side. So we did an automation and brought protection and detection both at the same application infrastructure or the framework. And then the correction is the important point of it, where what we did is, when we detected that this particular program is behaving malicious, is there a possibility by whatever the machine learnings that we have, and we know for sure that this is a malicious program, can I go and take an action on that? What happens with this is, without the intervention of any manual actions, I'll be able to take, I will be able to contain a malicious intended program. In the set of WannaCry, when it comes to a system, because it is new in hash, because it is polymorphic, I'm still be able to detect that because of the machine learning, right? One is that the protection is immediately I will block on the endpoint, right? The other one is, the last leg is correction. How did I do it? One machine had such kind of a program. Now, do I have the capability to identify if this program is existing in all of your system or not? So I do a discovery of those program, and correction in the sense, when I do a discovery, I will also take an action on that. Can I block it? Can I delete the program? Can I shut down the system? Can I restart the system? Can I block the network? So these are all some answers which can be given using our program or the software or the security software, whatsoever you want to call. Now, multi-stage defenses, we protected endpoint, we protected information going beyond your endpoint to the network side, or otherwise on the internet side as well. So multi-stage defenses, we bring in machine learning, as I explained. We bring single modular agent. When I say single modular agent, the protection was done by single agent. The detection was also being done by the same agent. The correction part of it also being done by the same agent. Means to say, one agent, all the different functions. You need not to have data leakage prevention as a different agent running over there. HIPS, right, program running as a different component, and AV running as a different component. So what we are doing is, we are cutting across over here and making this as one single agent which can do all these functions. But we run this on the back end as processes. We don't discount saying that one single agent would do all of them, but internal to our architecture, we have differentiated how the processes can execute. From a compliance standpoint, you will have to only check for one agent running or not. This has been a biggest challenge for any enterprise, to identify if that particular agent is running on the system or not. So the lesser the agents, the more compliant you are. So it's a graphical analysis of different components. We have centralized management agent called as EPO. The endpoints, the server, the SIEM part of it, the EDR, which is active response, MAR, you see there, the sandboxing. And there's a very unique technology called as TIE, Threat Intelligence Exchange, which gives the hash values of the program and says this is a new program which is running in your network, and its reputation seems to be bad because this has a malicious intent. So that information it quickly gives to the administrator as well as the management if required, and take actions based on something called as data exchange layer, right? Once the program is executed, all the elements which is running in your network gets that particular signature instantaneously, right? That's one of them. The example that I can give is you use ATM, you remit the money and you get the SMS in your mobile. How can that be possible? Because the protocols which are running behind is so fast, so quick. We call that as MQTT, right? The same program is running in our engine as well. So it is so quick. Once the infection comes in, all the endpoints get the information and then block it. So as summary, what we do is a static and dynamic analysis of the program which tries to run. If it is malicious, it maintains productivity, while patient zero is something the first time in the entire enterprise, first time this program is run by an end user. So we even protect that machine by encrypting. Generally what happens is, first time application is run, that particular system gets encrypted because of the virus infection. However, because of the analogy of that particular program has been run, the rest of the machines can be protected because we get the information that this program is running. In this case, what happens is, even that particular first could be endpoint or a server, wherever you run, even that is protected. Intelligence is shared across your enterprise, even in the cloud, even in the VM infrastructure or virtual infrastructure. That's the intelligence is being shared immediately. Smarter decisions based on the reputation of that particular program. Administrator has been given very decisive information saying that this program is malicious or not. And rapid search is something that a EDR program which we hunt it and delete the entire program, or as I said, we can take multiple actions over there, right? Unified workflows with marketing strategy, right? So that's what I had from a Mcafee standpoint. This is the program that we have brought, and I want all of you have a look at this, understand how exactly we have built this program, and then more than happy to share any information that you need. And I'm open to any questions that you have. Sure. Cross-platform, you're talking about Windows, Apple, yes. Yes, Linux, Mac, and Windows. This platform is. Sorry? Sorry, did not get it.
Does it support Dockers and containers?
No. At this point in time, we do not have an infrastructure. This particular agent runs on that. So yeah, we support the Linux, Macintosh, and
so just from my experience from Mcafee, so I was evaluating antivirus. So the main reason was that it did not support Linux. The kernel versions and all of it, there's a lot of restrictions in Linux, right? It's open source.
Yeah.
So how do you guys actually address that in this product?
So this particular agent will be supporting all the major versions after 11.
Okay.
Red Hat 11 version, and there are a couple of other Linux operating system that it supports. So whatever is prevalent in the industry, we support as on date.
Got it. Thank you.
Thanks. Any other questions? All right. Thank you.
Thank you, sir.